If you listen to Microsoft, it seems like Entity Framework is the only logical choice for data access. Almost every data access example uses Entity Framework. Yet if you've watched any of my videos, you'll have noticed that I do not use Entity Framework. In fact, I actively discourage people from using it. I do get a lot of pushback about the decision, and I also get questions about if the performance improvements of EFCore make using Entity Framework finally worth it. In this video, I'm going to review a very basic Entity Framework core setup and talk through some of the best practices to implement and the pitfalls to avoid when setting up Entity Framework. By the end, you should have a better picture of what it actually takes to create and maintain an Entity Framework data access layer in your application. And here's a quick hint. It's more than it seems like when you first start. Now, I'm sure you'll have an opinion on some of the things I'll share in this video, because I'll be sharing my opinion. I love to hear your opinion. Let me know down in the comments what your thoughts are. But let's agree on some ground rules. First and foremost, please be respectful of each other. Angry ranting and insults will get your comments removed, and you may even get banned from this channel's comment section. If someone's opinion of how to best develop C# applications makes you angry, I would recommend that you reevaluate your priorities in life. Second, if having a disagreement, please state the reason why you disagree clearly. We can all grow and improve in our understanding of software development if we have calm, informed disagreements. Finally, be willing to disagree or even to be wrong. Both are okay. I know I've grown as a developer because of the things that I got wrong and that someone called me on. Now, if this is the first video you've watched of mine, my name is Tim Corey, and it's my goal to make learning C# easier. One of the ways I do that is by teaching context. There are a lot of tutorials out there that teach you what to do. I go a few steps beyond that to show you when you should do it, why you should or should not do it, what pitfalls to avoid, and what the best practices are. This video is a prime example of me doing just that. Now, basically, I get you ready for the real world. Now, if that's the type of training you're interested in, subscribe to my channel and hit the little bell icon to be notified when I release new videos. They come out about every Monday and Thursday. Finally, in the description, there's a bunch of links. There's links to get the source code for this video, to sign up for my mailing list, to join Patreon, to get access to my courses, and all the links that I mentioned in today's video. Now, if you're looking to make a career out of C# or a better in your C# career, my content can launch you forward faster. Check out all that I have to offer at IAmTimCorey.com or sign up for my mailing list to hear from me directly. All right, let's go over to Visual Studio and set up our environment. Now, what we're going to start with is a web project. So let's create a new project. We'll create an ASP.NET Core web application. Hit Next. And let's call this EFDemo Web. How about that? EFDemo Web. And then the solution name is EFDemo App. You'll hit Create. And we're going to select a web application, which is the Razor Pages application with .NET Core and ASP.NET Core 3.1. No authentication, yes HTTPS, no Docker. Okay? This is just to have some sort of UI to work with our Entity Framework. So let's hit Create. And once this loads up, we can close out of this. This is a very basic project. You've probably seen one of these before, but essentially it's just a web application. If we run this, we should get a start page with just a privacy policy, I believe. So here we go. Make sure it runs. It does. EFDemo Web. There you go. Woohoo. Now the next thing we're going to do is add a class library. So right-click on the solution and say Add New Project, and we're going to select Class Library .NET Standard. So that's one of my recently used templates, therefore I'll just select it. But you could search here for library, and just make sure that the library you choose is .NET Standard. Okay, that's important. Not .NET Core, not .NET Framework especially. .NET Core would work just fine, but we're going to choose .NET Standard because that's the default library right now that you should use. And the reason why is because .NET Standard will work with .NET Framework projects, it will work with .NET Core projects, and it will work with Xamarin projects. It will work with pretty much any project in the Microsoft ecosystem. So it's kind of a very, very versatile class library, whereas .NET Core is a little more limited. It won't work with .NET Framework. So .NET Standard for now is the way to go. Hit Next, and we'll call this our EF Data Access library. Hit Create, and we delete class 1. Okay, with that being done, we have our class library. Let's add a reference. Well, we'll wait to add a reference until we actually add some classes to it. So let's add a folder to our class library, and we'll call this models. Inside the models folder, let's add a class, and let's call this person. We'll start with person. You know what? Let's start with address first. This is our address model. Address, not address model. That's a little bit of a different naming convention, but it's more in line with what we use with Entity Framework. I do try and conform my conventions to what I'm using. Okay, so let's create a quick model. So prop, tab twice to get our property, and we're going to start off with an ID, and then we'll have a string for a street address, and we'll have a string for city, a string for state, and a string for zip code. Now, you may wonder, if you're in the US, a zip code looks kind of like this, 5 numbers, and so it seemed like that'd be a number, not a string. But a zip code can also look like this, and that is a string. And then if you're in Canada, I believe you have letters in it. So depending where you're at, this is not a number. But even in the US, it's not a number because we have things like that is a valid zip code or close to it. So leading 2 zeros, that's not how a number looks. That would be something like that. But that's not a zip code. A zip code is 5 numbers. So you'd have to pad it with the first 2. So therefore, we store zip codes as string. We also don't do multiplication on zip codes or addition or subtraction. Therefore, it's not really necessary to store it as a number. We store it as a string. Okay, little side note there. All right, so there's an address model. It's going to hold 1 address. Let's add another class, and let's call this email. And make it public. And an ID, and we'll call this email address. That's all it's got in there. And then we'll have one more model, and this is going to be the person model. So public class person, and we're going to have an int here. That's an ID, and we'll have our first name, last name, an age, and then a list of address model called addresses. And we'll make sure to instantiate that so you can start adding to it right away. And then a list of email called email addresses. And instantiate that as well. Okay, so there's 3 models that hold related information. So you have a person, and a person has a first name and a last name and an age, which typically you wouldn't store age as an integer in your database, but this is for example purposes. And then they have a list of addresses. Why would a person have a list of addresses? Well, if you have a summer home and a winter home, or if you have If you live with your father for half a year and your mother for half a year, or there's a bunch of different reasons why you might have multiple addresses. Your work address and your home address. Again, there's just a lot of reasons why you might have multiple addresses. Email addresses. I have probably 12 of them that I actively use. And I have more that are occasional use. So one email address wouldn't be enough, but a list of email addresses would work out just fine for me. Okay? So pay attention to those kind of things when you have your setup. Make sure you don't just have one address. I've seen this done before, where you have one address and then later they go, oh, this person has two addresses, so we have to add another property called address2. And then another person has three addresses. And before you know it, you have address 3 and 4 and 5 and 6, and that just gets silly. So don't do that. That's what you have the lists for. Okay? So let's now start setting this up to use Entity Framework. So let's right-click on our dependencies of our class library. Go to Manage NuGet Packages. And we're going to install Microsoft.entityframework.SQL Server. I'm sorry, Microsoft.entityframeworkcore.SQL Server. So this is what we want to install. This will set us up to use Entity Framework with SQL Server. Now there's other options as well. If you want to use SQLite or MySQL or other options that EFCore supports, that's fine. But let's go ahead and install Entity Framework Core. Okay. Now, as we're doing this, I do want to point out that the tooling here is really impressive. And that's one of the things that people often get confused on when they hear me talk about Entity Framework. They often think that I'm not a fan of the tooling. And that can't be further from the truth. The tooling is excellent. It allows us to quickly stand up powerful data access code with very little work. It provides great features such as database source control, rollback, and a lot more of those kind of features. So when we talk about the tooling here, I am really impressed with the tooling. That tooling is not what I have the issue with. So as we go, just try and separate your mind the tooling from who uses the tooling. That's the issue that I have the problem with. It's not just about the fact that what the tools do. It's about how they're most often used and how much you have to know to make them used in the right direction, or make them used as efficiently as possible. Let's put it that way. Okay, sorry, my tongue's a little tied. Okay, so let's right-click on our class library, create a new folder. We'll call this just data access is fine. And in here, I'm going to create a class. I'm going to call this class the people context. And context is a pretty common keyword for Entity Framework. So public class people context, and that's going to inherit from DB context. Control dot to add the using statement there. So we have our people context, which is inheriting from DB context. Now the first thing I'm going to do is create a constructor. So public people context. I'm going to pass in DB context options. We'll call them options. And then I'm going to call base options. Okay? And so what this does is it gives us a constructor if we want it, and it also calls the base constructor with those options that have been passed in. Okay? So we're going to leave this alone. We're not going to actually fill that in with any code, but I do want to have that set up. Now, here's where we set up essentially our tables. So public DB set for type person. Control dot to add our using statement there. So for person, and we'll call this people. And this is a property. So I should have done a prop, but get set like so. So prop DB set, and this is for address. And we'll call this addresses. And DB set for email. We'll call it email addresses. Okay? So there's our essentially our three tables you can think of them as. These are our sets of data. So again, it didn't take much to get this set up, and this is pretty much all we have to do on the code side to have Entity Framework configured. Well, almost. Let's do that last code piece, which is go over to our front end, and this is where I have my first squeamish moment. My first moment of going, I'm not sure I like that. And that is we have to set up our front end in order to finalize the configuration of Entity Framework. Now, there have been some changes recently that I believe have made this better, and it might be you can get away with not having a front end anymore. They've been working on that, but I have not seen where that is. And if you do know how to do it without the front end, I'd love to hear it. Okay? But the way I do this is to add a reference to your library in the front end, and then down in Startup, we're going to configure this. So in the configure services, we're going to add our DB context. So up here, we're going to say services dot add DB context, and then we're going to say people context. Control dot to add that using statement. So the people context, and then we're going to say options, and our arrow function here, and inside here we're going to configure our options. So options dot use SQL server. Control dot. Notice here using Microsoft.Entity Framework Core. This has to know about Entity Framework Core. This is the front end. Again, not a huge fan of that. The front end knows now that we're using Entity Framework Core and how we're using it. So configuration dot get connection string, and the connection string will be, let's just use default. Okay. So what is this doing? Well, this is configuring or adding our DB context to our dependency injection system. And it's configuring it to use SQL Server, and the SQL Server connection string is getting pulled in from our configuration, which is this app settings.json. Now we need to add that connection string. Connection strings, plural. And then here we can say default and have our connection string. Now I'm going to use a local DB, which if you go to SQL Server Object Explorer, you can probably find local DB. And the cool thing is, if you already had a database, you can grab that database. Let's just grab, it doesn't really matter. Delete me is fine. If I select delete me and say properties, if you already have a database over here, one of the things it does is you can copy this connection string. See, it says connection string right here. You can double click, copy, and then paste the connection string in. And it gives you all the good stuff here you need. In fact, more than you really need. You don't have to have all this stuff. That's really all you need, is those three pieces of information. The data source, the initial catalog, and the integrated security equals true. Okay, so let's talk about these three things. The data source is the location where your local DB is. You can hand type this. You don't have to do the copy and paste like I showed you. You can hand type it. But it is going to be different based upon your environment. And this is one of those things that trips people up. They copy my connection strings and then wonder why they don't work. Well, the connection string is based upon your installation of local DB. If you don't have local DB installed, this won't even work. If you go to Tools, Get Tools and Features, I'm not going to do it here, it takes a little bit to load, but what that does is it allows you to configure your Visual Studio and look for SQL Server Data Tools as one of the options, one of the big options. Check the box and that will install local DB for you. From there, go to your View menu and make sure you select the SQL Server Object Explorer to open that up, which that's right here for me. And then you can connect to a server. See this little Add Server button here, and you get to punch in the credentials. It's going to look for items locally. So I can select this, see MS Local DB, I can hit connect and it will connect to it automatically, or you can find other ones on the network or even Azure. So once you connect, then you see this name right here where it says localDB in parens / MS SQL localDB. That's the name of my server. That whole thing from the parens over to DB. So that's the data source right here. That's what I'm going to put there. Next, we have the initial catalog. This is the database. Now, Entity Framework code first, which is what we're doing. We're writing the code first and having it generate a database. Code first starts with no database. You don't have a database. And so we don't want to use an existing database like delete me. We want to create our own. So let's create our EFDemoDB. Let's just check to make sure there's no EFDemoDB. There's an EFContactDB and EFData, and that's it. So there is no EFDemoDB, which is good because we're going to create it. All right, let's capitalize that B. So we have our new database will be called EFDemoDB. Finally, integrated security equals true. This is saying that whoever is logged onto the computer use their credentials to log into the database automatically. Now, it does not know your password. It's not using your password. It's using your authentication token, essentially. I mean, that's kind of the boiled down version of it. So it's saying, hey, you've already logged into Windows, and therefore we're going to use the fact that you've logged in, you've told Windows who you are, and Windows says, yes, that's who you are. We're going to take that as a good sign that's who you really are. Therefore, we use that person as the person to log into the database. That's great for a demo environment. But unless you're on a local network that has an Active Directory, you probably can't use that in production. In production, you'll probably use a username and password to your SQL server. Now, we'll get back to that in a bit, but that's a pretty common occurrence. In fact, you have to do that almost always when it comes to connecting to a database. Usually, you're connecting using a username and password, not integrated security. So we'll talk about the downsides of Entity Framework specifically when it comes to that username and password. But just note that all database connections use that username and password unless they're using it as integrated security on a local network. All right. So with that, we've got our connection string. We've got our DB context in our services. And we're pretty much ready to go from a code perspective to start using Entity Framework. But we're not done yet. We now have to create our actual migration scripts and then create our database. Now, what are these migration scripts? Well, let's make one quick modification. Let's actually get rid of age from it. Let's just say we forgot to add that. Okay? We'll come back to that in just a minute. But now let's create our migration script for our data access library. So you go to Package Manager Console. If you don't have Package Manager Console, you can go to the View menu and then go to Other Windows. And down here is Package Manager Console. So open that up, and this has access to Entity Framework. And so you can do things like this, where you say add-migration, and then give the migration a name. So this first migration is initial DB creation. Okay? And I hit go. And it says, oops, not yet. Let's find out why. And it says the add migration is not recognized as a name of a commandlet, function, script, file, or operable program. Why is that? Well, they haven't added the tooling to my project. So on the web project, again, here's another one of those places where I twitch a little bit. Right click on dependencies, say manage NuGet packages, go to browse, and search for Microsoft.entityframeworkcore.tools. This is the tools for the NuGet Package Manager console in Visual Studio. All right, so we will install these tools. And what this will allow us to do is from the package manager be able to do the add migration. Okay, now that we're done that, we go back to the package manager, run that same command again. It's going to build our project, make sure it builds. So if your project doesn't build, this won't work. So now it's succeeded. It says, nope. And it's saying, hey, your target project of EF Demo Web, which that's our startup project, doesn't match your migration assembly, which is EF Data Access Library. This is the next area where there's a little bit of a twitch factor on my part. By default, Entity Framework really loves to be in your user interface. It loves to be right next to your UI, right embedded in it. In fact, a lot of the tooling around web projects talks about Entity Framework. Now, if you've ever worked through the idea of separation of concerns or loosely coupled applications, or if you've gone through any of my content, you will note that that's not really great, because then your project is, your UI is your entire project. It's everything. And so if you decide to change your UI, you pretty much have to change your entire project. And that's not great. Now you can probably reuse some code, copy and paste, whatever, but it's a major overhaul to replace your user interface. Where if you have that separation of concerns where your user interface doesn't really care where your data comes from, it just says, give me data, and your data access layer says, oh, here you go, and it gives it to it, then if you go to replace your user interface, it's just that top layer you're replacing. You're not replacing your business logic. You're not replacing your data access code. And that's where I'm not a big fan of how this was originally designed and built. Now, there have been improvements around being able to separate these two. Notice I have put Entity Framework in a class library. And as soon as I change this dropdown to say default project is EF Data Access Library, I believe this should now work. And there we go. So it's done. But it's those little things where it's actively encouraging you to put it in the user interface, because not putting it in the user interface is just a little bit harder. And that's one of the concerns I have. And here's my biggest concern with Entity Framework. It's that you have to know a lot in order to be an Entity Framework developer. In fact, I would say that you have to be you should be an advanced level user before you start using Entity Framework. The problem is that Entity Framework is so easy to start that it becomes a beginner level data access ability. And that's dangerous. And that's where I have the problem. Remember before I said that the tooling is excellent? It is. The tooling is excellent. The problem is it's designed, it really needs to be in the hands of an advanced developer, not a beginner level developer. And that's not to be a gatekeeper. I do not like gatekeeping. I don't want to ever say you can't because you're not in a special club. What I'm saying here instead is that it's very, very dangerous to use Entity Framework until you understand some of the advanced pieces of it. So let's dive into one of those advanced pieces, and that is the migration script. So what a migration script is it's the way the Entity Framework builds out your database. So you start from no database, and then you migrate to a database. And then as you have more changes, you migrate from your existing point in time of your database to a new point in time. And that's what these migration scripts are. Notice that we have a migrations folder now. And in here we have this new file that starts off as 202001110333618 underscore initial DB creation. Notice the end part there, that was my name that I gave the migration. That's the name right there. So this is a migration. And this is automatically generated code based upon our DB context, our people context right here, and the objects that are DB sets inside of it. So what is this? Well, there's two methods in here. And this is pretty cool. This, again, the tooling is great. I love the abilities this tooling has. It has two methods. One's up and one is down. Now, just at a random guess, what do you think these do? Well, the up migration allows us to go from where we're at to where this wants to take us. The down migration is a rollback. So if you've done the up command and you go, oop, that didn't work, you can roll it back using a down command. And that will undo what you did. And that sounds awesome, and in reality it is pretty awesome. However, just note that that down command isn't all rosy. Because in our example, the down command for this migration script is to drop this table, and drop this table. Basically, delete all the tables in our fledgling database, which is fine if you just created them. But if you already had data in them, that data is gone. So it's not like these rollbacks are without cost. There can be a time when you lose data because you do a rollback. So just know it's not a silver bullet. You have to be very careful doing a rollback. It's not something to do lightly. Okay, so that's the down command where it says drop these three tables. That's the rollback. Let's look at what we do to create those three tables. Well, we have create table, the people table, and it says columns. Now, all this code gets written for me, which is great. I don't have to write all this syntax or even know all this syntax. And sometimes people say, well, you don't even have to look in here because who cares? But here's the deal. This goes into source control. Do you know why it goes into source control? Because you have to maintain it. Yes, something else wrote this code for you, but it is your responsibility to understand it and know it because this is your data, not Microsoft's data. This is your database. If something goes wrong, you're on the hook, not Microsoft. So let's read through it. The people table. We have an ID, cool. Int, excellent. Not null, says null equals false, cool. Annotation says SQL Server identity 1, 1. What does that mean? Well, by default, what it's going to do is it's going to make this an integer column, which we already called an int. That's what it just took from us. But then it says this is an identity column because you called it ID. And this identity column will start at 1 and count up automatically. That's perfect. That's exactly what I do. So the fact that it did it based upon the fact that I just had int ID in there is excellent. I love it. That's great. Next one. First name, table.column. It's a string. It's nullable. Okay? That's not ideal because first name and last name can be null. I don't want them to be null. We'll address how to fix that in a minute. But just note that's the defaults. Now, constraints. Well, we have a primary key, and that primary key is based upon the ID. So it made the ID column a identity column, and it made it a primary key. Cool. That's exactly what I would do. Address table. Well, we got the ID, same deal there. Street address. It's a string column. It's nullable. Same with city, state, zip. Those are all string columns, and those are all nullable. Again, I would make these not null, but besides that, it looks good. Then we have this person ID. Well, we don't have a person ID in the address column. Notice there's no person ID here. So where'd that come from? Well, in the people or the person table or object, we have a list of addresses. So it said, oh, you have a list there? Well, we're going to put the ID of the people table in our address table so it links. Cool. And that's an ID, and it is nullable, meaning you don't have to have a person ID. Well, that's kind of a problem. Why would we ever have an address that didn't link to anything? So that's another problem right there. Then we have, under the same still addresses table, we have a primary key. Cool. Then we have a foreign key. And the foreign key says, from the addresses table, link to the people table, the person ID. This is the almost exact same naming convention I use, which again is awesome. Now, part of that comes from using a standard naming convention, because then your convention matches up with everybody else's. But what it's saying is, link the person ID column in the address table to the people table, the ID column. Excellent. And for the foreign key, it's saying on delete, restrict. What that means is you can't delete a person if they have a linked address. Again, perfect. Let's move on to the email addresses. It's the same basic story. We have our ID, that's an identity. We have an email addresses, which is a string. It is null, which again makes no sense, because if you have a null email address, then why do you even have an entry? That's the only real piece of data here. The rest is the ID of the record and the ID of the person we're linking to. So there's no reason to have a null email address, but yeah, it's marked as nullable. Okay, again, primary key and a foreign key, because this links back to the people table. Then we also have a index for the address person ID. So we're indexing the person ID column in the addresses table and the email addresses table. And what this does, it creates an index so that it's quicker to query data based upon that ID. So that's pretty good as well. So that's what gets created in our first migration script. Now, before we go any further, I'm going to come back over to the person table and say, oh, you know what? I forgot I wanted to add age. Let's put age back in. Now what do I do? Because age is not in the table. Well, I go back to my package manager console. I say add migration, but I give it a new name, add age column. And I create a new migration. All right, and so now I have a new migration. So now I have a second one right here. And this one says up is to add a column called age to the table people. It's not null, and the default value is 0. Down is drop the column age from the people table. So now I have 2 migrations, and we'll apply these in just a minute. But I just want to show you that you can have multiple of these, and you will have multiple of these as you make changes. So whenever you make a change to one of the models that is one of your tables, then just do a new add migration at the package manager console and create a new migration for whatever changes you've made. Now, there is one more value that has not, or one more class we haven't talked about, and that's the people context model snapshot. Now, at the very top, it says this has been auto-generated. So this is auto-generated C# code. And this is a model snapshot. And so it has some setup here. Again, you don't necessarily have to know all the information that's going on here, but it is pretty important to understand how to read it. Because if we look here, let's start with the entity, the address model. And let's come down here. It says the property ID value generated on add. Well, that's the identity value in SQL. That's saying it starts at 1, it counts up every time. That's the value generated on add method. That's what it's doing. Has column type of int. Cool. Has annotation. And there's the annotation that says it's identity column. Okay, so that's at least understandable. Next, we have the city property, which is a string, has column type. Here's where you specify the actual SQL column type for city. That column type is Nvarchar max. Now, if you're not familiar with SQL Server and how it does the different column types, let's talk through what Nvarchar max really means. So first of all, Nvarchar, what is that? Well, that is a Unicode variable length character field. So Unicode is a wider character set than we have typically in the US. So in the US, this is our character set, what you see on the screen. So you know A through Z, uppercase, lowercase, and a few special characters. But in the rest of the world, there is a wider range of characters that are used. For example, any of your Arabic languages do not use the ABC alphabet. The same with the Asian languages. And there's a whole bunch of other cases where the characters go beyond ASCII. Okay, ASCII I believe is 65,000 characters maybe, something like that. And that's just not enough. And so what we do is we use Unicode instead, because Unicode it's I believe millions of different characters, including emojis, if you want to have emojis. So Unicode is much more popular for storing data that might have to do with any type of international or even just non-ASCII character set. So that's a good thing, but it does take up twice as much storage as ASCII storage or Nvarchar, because Unicode takes up 2 bytes per character, whereas ASCII takes up 1 byte per character. So just note that Nvarchar will take up 2 bytes per character. That's fine, because really when it comes to storage anymore, storage is usually not the limiting factor. Now, typically, you would put a number in here from 1 to 4,000 for Nvarchar. And that would indicate the number of, I guess, roughly equivalent to number of characters that it can store. It's not quite a one-to-one relationship. There's a little bit of a difference there, but think of it as characters. So 1 to 4,000 characters would be in an Nvarchar column. But what if you wanted more than 4,000 characters? Well, then you would have Nvarchar max. Nvarchar max can hold, I believe it's 2 gigabytes worth of text. Someone once put it's something like 141 copies of War and Peace written out, something like that. So very, 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 very large. However, SQL Server has a limit on the number of bytes it can have in a given row. That limit is 8,060. So once you hit 8,060 bytes in a row, you have an issue. And so what they've done is they said, okay, for Nvarchar max and for Nvarchar max, what we're going to do is if those are large values, we will store them on the disk instead of in the database. And we'll put a pointer to where they're at on the disk. This makes it very easy for SQL Server to stay in that 8,060 byte limit per row while still having massive amounts of data per row. However, it does cause some problems. I know I'm getting a little deep into SQL here, but this is important to understand when working with Entity Framework. So if you store a value that's a max value or a large value in this field, it's going to store it in a different location, which means the querying for this row is going to be different. In fact, it's much, much harder to do things like finding values inside of an Nvarchar max because it's going to disk. And so it may even tell you can't do it, or it may be a much more expensive process for lookups. Now, most likely for the city, you will not put more than 4,000 characters. In which case, SQL Server will treat it like it was however many characters you put in there. So if you put 20 characters for your city, it's equivalent of having Nvarchar 20 for that particular row and column. And you may say, well, then great, Tim, what's the problem? Well, there is a couple of problems. The first problem comes down to indexing. Remember back here, we talked about the fact that down here it created a couple of indexes for our address table and for our email address table based upon the person ID. And the reason it did that is because it makes it faster, or it can make it faster. Let's preface this. It can make it faster to put an index on something you're going to be using in a query, where your query had a where statement or something of that nature, or you're joining on it. What if we were going to query based upon the city a lot? So that was in the where clause, a lot. We say, oh, well, let's create an index for that. Not so fast, because it's an Nvarchar max. A non-clustered index has a limit of 1,700 bytes. Well, the Nvarchar max is well beyond 1,700 bytes. Therefore, you cannot put an index on this. Therefore, you may have an optimization problem. You may not be able to optimize your database lookups based upon your columns because your columns are too big to be indexed, even though the data inside them isn't too big. So that's problem number one. Problem number two is one that it's not, I definitely want to give credit where credit is due. I was doing some research on this and just asked the question, hey, is there a performance problem with Nvarchar max? Because if we put 40 characters in there, it's no different than Nvarchar 40, right? Well, the answer is no, that's not correct. So, right down here, Eddie did a little bit of work on this, where he figured out how to set up a bunch of different columns with a bunch of different sizes. So we have Nvarchar 64 through 4,000 and then max. And the same with Varchar through max. And then he did some query lookups and found something interesting. And what was interesting is that the storage space is based upon however much you actually use. However, when you do a lookup, it has to know how much memory to allocate before it gets your data. So with this, he found that Nvarchar and Varchar columns are assumed to be half full. Imagine how much storage space and capacity in memory we're going to take up for a column that is Nvarchar max, especially if, as we go back to here, we'll notice that we have state is Nvarchar max, street address, zip code, and if you come down here, so is email address, all Nvarchar max. Essentially, any string that we do will be Nvarchar max by default. How much memory are we going to use up? Well, he did a little bit of searching and did some querying. Now, I will provide this link in the description. You can go and look and try it yourself and see if you get different results. But he did it multiple times and even rebuilt it with row level compression, and the results were the same. So if we look at the Nvarchar max down here and do the query, look at the memory usage in kilobytes. 272. Even though up here, where we have the Nvarchar 64, now the data is the same. There's not a difference in what data is in each of these columns. But just because a column type was Nvarchar 64, we get a null value for memory usage. That's because it's less than 5 kilobytes. This should be KB, not MB up here. But it was less than 5 kilobytes of memory usage. But down here, for the same exact query, just a different column type, it's 272 kilobytes. Now, usage percentage, 2%. So it allocated 272 kilobytes of memory on our SQL Server for this one query, and it only used 2% of that memory. That's a real performance issue. Because remember, this is not going to be something you run once. This is something that everybody that uses your application is going to be running. So 5 kilobytes or less, actually, versus 272 kilobytes. That's at least, 50 plus times more memory usage for the same exact query for one field? Imagine what would happen if you had, 1, 2, 3, 4 fields that had Nvarchar max. What could the performance implications be of this? So that's the next thing I want to point out, is that by default, Entity Framework does not create the ideal table design for you. It's expensive, the table it creates. And why is that? Well, this is not because Entity Framework is dumb. In fact, just the opposite. Entity Framework is very smart. So when we say string street address, how much data can you put into this property? As much as you want. There is no limitation here. It's massive, the amount of data we can put in here. We can load an entire JSON file into one string variable. So if I were to store that in a SQL database, how does it know what to assume that size should be? It doesn't. There's no way it can know how much that property is going to hold. Therefore, it has to cover all the possibilities. And that means it has to say Nvarchar max. Well, that's not ideal. So we're going to have to change that. So that's one of those things where out of the box, it's going to burn you. And it's going to be less performant. And one of the things that I have talked about before and people have pushed back on is the idea that Entity Framework is not efficient when it comes to data access. And I get a lot of pushback on that, and one of the big things was, well, with Entity Framework Core, that's really changed and it's really efficient. And my response is, no, it's not. It can be. And if you write a really good optimized bit of code, you absolutely can make this a really performant system. However, that indicates that you are an advanced level user that knows how to diagnose and improve queries in Entity Framework. You're proving my point to me that Entity Framework is not for beginners or intermediate developers. This is for advanced developers who have a firm grasp on the ins and outs of Entity Framework. Because pretty much every demo you'll see online, it'll look like this. It'll say, there you go, create your model, and then create your migration script, and boom, there you go, you got your application running, and you have data access. But again, all 4 of these, Nvarchar max, not a good thing. Okay, next, let's walk through here. Person ID is a nullable int. Don't like that. Now it does line out has the key for ID field, has index on these 2 fields. That's cool. Down here, pretty much the same story. We've got Nvarchar max. We have our identity column here. We've got our nullable integer, and we're creating our indexes, our index, our key, and we're assigning it to the table email addresses. Down here, person, again, same thing pretty much. And then down here we have our linking. So it has 1 in the person and has many in the addresses. It's the one-to-many relationship here, which is good. That's ideal. So you have one person can have multiple addresses, but each address is only linked to one person. Okay, that's a one-to-many relationship. All right, same with email addresses. Okay, so we've found some issues in our code, but but that at least walks us through, and now we have a better understanding of what this migrations folder holds and how it works. Now, before we go any further, we are going to update these models to make them better, but let's go ahead and create our database. We haven't done that yet. So in the Package Manager console again, this time we're going to say update-database. That's it. Hit enter, and what this will do is it'll create our database. Now, what database does it create? Well, it creates the one that we specified in our startup class. I'll go to that in just a minute once this succeeds. So the build has succeeded, now it says done. So we create our database. So it came through in our user interface and it said, hey, your DB context. Oh, you said you use SQL Server, cool. And there's the connection string, which is default. So let's open up app settings.json, find default. Okay, there we go. We're going to create the database named EFDemoDB in the local DB/MS-SQL local DB database or server. And we're going to use the integrated security, which means whoever's logged onto the computer. So EFDemoDB, let's refresh our databases here and find the EFDemoDB. And notice we have 4 tables. We have people, email addresses, and addresses. Those look familiar. And in fact, if we were to open one of these up, let's go to view data here. We'll look at that in just a minute. But we have this EF migration history, which actually starts with an underscore. And what this does is it gives us a history of what's going on in this database. And it said, okay, I have run this migration and I've run this migration. So it's run 2 migrations. This happens to correspond to the 2 migrations I have over here. And so based upon that, it knows where it's at. So if I were to run update database again, nothing would happen. Nothing would change in my database because it's already run those 2 migrations. And so it knows that. So it knows, okay, if we run update database again, look for any migration after, add age column. Again, really smart tooling. The people table, notice ID, first name, last name, and age. Again, all nulls. We have no records in this table yet. All right, so we now have our tables, but they're not ideal. They're not designed really well. In fact, if we look at the address table, we go to the view designer, we'll see that there's Nvarchar max for all of these. That's really depressing. Let's change that from Nvarchar max. So let's start modifying this to work better. So first of all, street address. This should not be null. Let's mark it required. Control dot to add our using statement up here for system.componentModel.data annotations. Now this will not be marked as nullable. That's a good start. Now we need to mark it as not an Nvarchar max. So let's say max length is going to be, and let's just say 200. Okay, so that's our street address. Let's copy that and let's go down to city. City should be required, but it should be a max of 100 for our length. State, a state should be more like, I don't know, 50. The states that I use for my demo or my sample data, they're not state abbreviations. They're actual states or names, longer names. So 50 is probably fine. And then let's do the same for zip code. And zip code, let's say the max length is 10 because we're going to use the US notation. So it'll be 12345-0000, something like that. That's our zip plus 4 syntax, which that's 5 characters, that's 4 characters, and that dash does count, so that's another character as well. So 5 plus 4 plus 1 equals 10 characters. That's the max our length should be. Now, a zip code is not Unicode. Doesn't need to be Unicode. There's no reason to store 2 bytes per character because it's going to be, again, we're using the US based here, but it's going to be a number from 0 to 9 per character slot or a dash. That's it. Those are all ASCII characters. So let's change this to Nvarchar. Well, how would you do that? Well, you're going to say column, control dot, add using system.componentModel.dataAnnotations.schema. And then you're going to say type name equals Nvarchar, and then let's give it our length of 10. So now you're putting into your C# code SQL code or SQL commands. Is that ideal? No. But that's what you have to do if you want to be more efficient in your database, which you do because your database, the faster it becomes, the faster it runs, the faster your users get served. And here's one of those things that often bites people with Entity Framework or Entity Framework Core. Doesn't matter. When you're using this in development, it is all very, very, very responsive. In fact, we looked at that web page before, and let's bring it back over here, and we talked about 272 kilobytes of memory. You may have laughed at that because, come on, Tim, 272 kilobytes of memory. I have 16 gigabytes of memory on my personal development machine. That's absolutely true. If you have that much, you will not have a problem in development. And in fact, your server probably has even more than that. However, how many users do you have or do you want to have in your application? If at first you have 5, 10, 15, 20, not a problem. And so these problems will lie below the surface until your application becomes popular or until it goes into production in an environment that has lots of users. And by lots, I mean dozens to hundreds. Now, not even talking about thousands and millions, just dozens to hundreds. But once that happens, once it goes into production, and let's just say a couple hundred people are using your application, a couple hundred people times 272 kilobytes of memory for one field times 4 fields, that's a lot. So all of a sudden, now you're talking about megabytes and gigabytes of data being used by your users. Memory is a limiting factor in applications. So now you've designed an application and it's running and you've built it all around Entity Framework and it's worked great up until a certain point in production. And at that point, now what do? It's too late to re-architect your application because it's already in production. It's already been written against. It's probably grown beyond just a simple little application. It's a lot bigger now because it spent some time before it really ramped up in its usage. Now you're up a creek. Now you've got a problem because your application is based upon a foundation that worked great in development, that worked great in test, and it worked great with small sets of users. When it got big, that's when you ran into problems. And that's when you have to come back and do all these optimization steps to hopefully get your application to be more performant for your user load. And just hope the user load doesn't get to the point where there's other performance issues that come in as well. And we'll see those in just a minute. So with this, now we have our address configured to be a little more optimal. We go to email address and do the exact same thing. So first, required. Control dot to add our user to it. And then we also need to say that the max length, and let's say our max length for this is, again, 200. We'll still do Nvarchar. I don't know the email addresses can have a Unicode character in them. I believe they have to have ASCII characters, but I'm not positive. But if they did, we'd have to add something similar to what we did here in order to save half that memory usage, if we could, to set to Nvarchar instead of Nvarchar. But we'll leave it at Nvarchar, but I did want to have at least one of these in here to show you that this is what you have to do in order to make these modifications. Okay, person. So required, actually I think I have pasted in here. Yep, I do. So control dot here to add our using statement. So now first name, let's say that that is, 50. And we'll do the same thing for last name. It's going to be 50. Age, it's just required. And then addresses and email addresses, we'll leave these alone. Now I've made some modifications to our models. So we have to come back to the package manager console and say add migration, added validation, and hit go. Let it build. Once it builds, it's going to create a new migration script. And it does give us this yellow warning. An operation was scaffolded that may result in loss of data. This is no big deal if you are still in the development process and still building your application out. However, if this was in production and you had an issue, a performance issue, and you found out about it and go, oh, Nvarchar max, let's change that to Nvarchar 100s, and let's change it to, that zip code to Varchar 10. That's cool until you get that yellow message. Because then you start freaking out because you can't just run this update migration. If you do, you may lose data. So, because you allowed Nvarchar max for all these different columns, if let's just say the first name, which we've set down to be 50 now, let's just look at it, the max length is now 50. Well, what if you already had somebody's name in there that was 60 characters long? Maybe it should be there, maybe it shouldn't be, whatever, it's there because you allowed it. It's Nvarchar max. Well, what it's going to do is going to truncate that name to only 50 characters. It's going to cut off the last 10 and discard them. You will lose data. What if for our zip code we change to Varchar? Well, we were allowing Nvarchar max. So if we have a zip code that has Unicode in it or it has 100 characters in it, again, we're going to eliminate or replace the Unicode characters and we're going to truncate at only 10 characters, losing all the rest. That's why you need to check this stuff out before you go to production because otherwise you're going to do a lot of testing first to see what data you will lose. And that means a lot more SQL work. So let's look at this migration script. Alter column, last name in the people table. The max length is now 50. It's now not nullable, so nullable is false. And the old type is Nvarchar max. So it's saying, and it was nullable. So this is what it was. And this is what it is now. Now notice up here it does not describe the type. Because the type was Nvarchar max, the only thing we changed was the length, therefore it will still be Nvarchar, but the length will be 50 now. Let's look down at the zip code again. There you go, zip code. This did change the type. So the type is Nvarchar max. The old type says, whoops, I'm in down. Sorry, I skipped down too far. I was wondering. There we go. So the type is Varchar 10. That's the new type, and the max length is 10. The old type was Nvarchar max. So notice that the new type is Varchar max. So there we see the change in type, not just the length. So if you don't see the type change, that means it's implied. So there's no type change up here. That's implied based upon the old type of Nvarchar. It's just that the length has changed. So again, we have our up script, which is going to do these modifications, and our down script, which is going to roll them back. Now again, rollback sounds great. It sounds like we'll go back to a point in time where you were before. Well, no. A rollback means it will change the schema of our database, the architecture of our database. It will not put back the data that it deleted. So if you do an up here and you delete data, let's say you have names that are 100 characters long and you cut half of those off, the rollback will not get those 50 characters back. they're gone. You have to go to your backups, your SQL backups, to get that data back. Okay, so just be careful when you're thinking about rollbacks. It's just a schema rollback. It's just rolling back our SQL scripts. It is not putting data back. So if your migration deletes data, it's gone. If your rollback deletes data, it's gone. Whatever you do, make sure that if you're going to lose data, that you know about it beforehand and you either change what you're doing or you're okay with losing that data. Because once you run the migration, either way, that data is gone. You have to go to your SQL backups to get it back. Okay, so now we have this. Let's update our database. And yes, we don't care about our data. It's not really anything there. So we're good to go. We did an update database. And now our database, if we go and look at it, let's look at the addresses is fine. Let's go to designer. And our designer says Nvarchar 200, 150, and Varchar 10. Cool. We still have that nullable int. We can fix that. I'm not sure if we will in this video or not. Basically, what you have to do that is you have to come in here to addresses. You'd have to create an ID and say this is the ID for the person ID, and then you have to make it not nullable. But we're already long. I don't want to go into doing that as well. This is not as much about teaching you how to use Entity Framework as it is what the best practices are for using Entity Framework, what to look out for, how to work with this. Okay, so now we have our database in. It's set up. It's ready to use. Let's actually use it. What I'm going to do is down in our, let's kind of minimize some of these things so they're not making too much of a mess. Down in pages here for our web demo, in the index page, we're going to put in the page model, we're going to put some code to actually work with Entity Framework, just to show what would happen, okay? The first thing I'm going to do is I'm going to import some data in here, some sample data, just to make sure that we have something in our Entity Framework database. Now what I did was I used a service where I can create temp JSON data. I'm going to bring that into our application right now. This generated.json, you can have this. This is generated on the web. And what this is a schema that's based upon my models. And it's just random data. So I said, give me a random first name, last name, and age, and give me 3 random addresses and 4 random email addresses per person. And I asked for 100 of these objects. So now we have 100 people with all their information. Okay? That's just to get us a little bit of sample data. 100 is not a lot, but it's something. So let's set up private void load sample data. And this method will be run probably all the time, but it's only going to run if the database doesn't already have data in it. But that means I have to know about the database. Well, I can come up here and I can say, give me a people context. Or that's the context for our database. Control dot to add our using statement. And I'll call this DB. And control dot to create and initialize my field. So now I have, from dependency injection, I have my people context. Remember back over in Startup that we added the DB context to our dependency injection. And we said it's a people context. So whenever you ask for a people context, you get back our context, which has access to our 3 tables. So now down in load sample data, I can say if, and this is why Entity Framework is so popular, db.people.count equals 0. What did I just do? I just queried the people table and said, hey, if you don't have any records, do this. Okay? With that one line of code. I didn't say, open a connection, nothing. I just said, you know what? Go to the context, go to the people table, and give me a count. And if that count equals 0, we're going to do stuff. So that's really convenient. I'm going to show you the downside in just a minute. So let's start with string file equals system.io.file.readAllText from generated.json. And that's this generated.json file, which is in the root. Let's just go to our properties and make sure that it is, in fact, copying. It is copy if newer. So this will be in our output, our build folder. So we now have read the file, all the text, into this variable. Again, remember, a string variable can hold as much as you want. So that string variable file has all of our generated JSON. I'm going to say var people equals JSON serializer, control dot add using system.text.json, JSON serializer dot deserialize to a list of person from the file. And person control dot to add our using statement there. So it's going to get a list of person from this file. It's going to deserialize it, which means it's also going to deserialize the addresses and email addresses because the person has a list of address and a list of email. So now we have, hopefully, 100 objects that have been loaded with all their email addresses and addresses. So now I can say underscore db.add range people. And don't forget, the last thing to do is say db.save changes. Now I'm not doing async, I'm just going to do straight up. This is just a quick and simple demo. So what will happen is we're going to load this temp data from the JSON file if there's no people already in the database, which there's not right now. We just created it. Then we're going to deserialize that into a list of person model. That's going to be people. We're going to add that list to our database. And then from there, we're going to save those changes. Now, how does it know where to add these values? Well, person. It knows what person is, and person has inside of it address and email address. So it's going to take care of adding all that for us. So I just ran an insert query on a whole bunch of items, and I'm going to save us all to the database. So a get query, 100 insert queries. Actually, more than that because each person has 3 addresses and 4 email addresses. So that would be 300, 400, and 100. That is 800 inserts. All with linking back to, so the addresses get created, but then they have IDs that link back to the person. That's a lot of complicated stuff. That was a really simple way of doing this. Okay, so let's call this method. We can call it every time we load the index page because it's going to do us check. Now, I'm going to show you SQL Server Management Studio. Why am I showing this now? Well, because I want to monitor that database. So I'm going to go to XEventProfiler, standard, double click it, and it's going to load up a profiler and start listening to any event that goes on my server. So there's a whole bunch of stuff here. In fact, I'm going to limit this. I'm going to say, you know what, give me only batch completes. So let's right click here, say filter by this value, and hit OK. So now it's just batch completes. And now notice there's a whole bunch of entries right now. But if I were to go over to, let's go to the, let's refresh this in case it's not refreshed. And it is our EF contact DB. Notice there's some more stuff going on here. And I were to do a new query window. And I were to say select star from DBO dot Contacts? That's not right. It's EFDemoDB. That's why. EFDemoDB. How about that? There we go. People. So select star from dbo.people. And I'm going to execute this statement. Come back over here, and if we look in our list here, let's scroll down the bottom, we're going to see this entry right here. Now it's already trying to get away from me. Let's hit stop real quick. And we're going to zoom in on this because it's a really small. But you see, select star from dbo.people. So it captured the command that I just ran. All right. So with that, we're going to be able to do a little bit of sleuthing as to what's going on in our database. Now, I'm going to start this up again. I'm going to filter it by the database and by SQL batch completed. So let's start this again. And again, this is a little more advanced SQL. Maybe you've never seen the XEventProfiler. Well, if you want to use Entity Framework Core or Entity Framework, you probably should get to know it because it's important when you're diagnosing what EF is doing on your server to know what queries it runs. This is going to tell you. So let's set it back up. It's starting to run, and it's a little slow. It's a little behind the time. That's okay. We're going to execute this query again. And there we go. So now we're going to change the columns here. So remove this column, and we're going to add a column. Let's remove client name. And we're going to add, select a record down here. You can come down to the values down here. I'm going to select database name, right click, show column in table. And then I'm going to do a filter. I'm going to say filter by, so right click on this and say filter by this value. And now it is EFDemoDB. Hit OK. There's just the DemoDBs. And let's get rid of this select at SPID. So filter by this value. And we're going to say not equal. So it's, again, it's a little small, sorry. We're going to say the text data is not equal that at SPID, but the database is DemoDB or EFDemoDB, and the name is batch complete. That's the one event I want to listen to. Hit OK. And now it's going to filter down to just DemoDB, and we've got a few less commands at least. And we can clear the data and start over. But let's close out of this first. And let's filter a few more of these out because we want to make this as clear as possible and not have any additional stuff in here if we can help it. So I'm just kind of filtering out the ones that are pretty common. They keep getting run over and over again. And say, you know what? No, I don't want those. I don't want those. Don't want those. Until I get a more reasonable list. All right. So still a little long. And let's get rid of this one. Let's get rid of this one. And let's get rid of this one. I would say not equals for all these. So there's my, and transaction count, we'll leave that alone. Okay, so there is what I have right now. Just the commands that I have made. Now, what I'm going to do is I'm going to start up my application. Now I'm going to start it up off screen because I want to put a breakpoint right, well, actually, let's start it on screen. We're going to put a breakpoint right here. So let's start this up. And now what's going to happen is when we first load the page, it's going to hit that breakpoint. Okay? Now to come down here, notice there's no events so far that are showing up on the screen. We haven't done anything yet. But let's step over this people count. Okay? Took a couple seconds there. And now if we look over here, we'll see we have a new command. And this new command says, let's zoom in here so you can see it. There's the command, select count star from people as P. Well, that's the command that Entity Framework just used to find out how many people or how many rows are in the people table. That's a really efficient call. Now, you may say, well, select count star, don't you do select count 1? Well, and that's my default, is I do select count 1, but actually, because SQL has gotten better and more intelligent, select count star is no different than select count 1. So therefore, it's just as efficient. So we can now leave this, and we do have some entries here, logical reads, writes, and duration. These numbers are, they're not really as intuitive or as helpful as you'd like them to be, but it does give you some reference when you're comparing two commands. So it may not be that you can go, oh, that's that took this much resources. It's kind of a made up number, usually, those numbers, but they are really helpful for comparison's sake, comparing one command or one call to another. So now that we have that, let's go ahead and run all this command. I like to hit F5 and run all of this. We're going to watch what happens to our command window. To continue, this is going to create 100 records. All right. And let's see what happens in our command window. And nothing happened. And I believe the reason why is because our filter right now is filtering on just batch completed. Let's put this one on pause for a minute. And actually let's delete that clause just for a minute. Okay. And now we have some extra commands because we have some RPC completed. And the reason why is we have some store procedures. So Entity Framework is calling store procedures. And you may say, that's cool, because everybody says that store procedures are great, or at least Tim does. And so what's it doing? Well, let's find out. So let's copy the statement. Let's just copy the value. So copy the cell, and then I will open up Notepad. Notepad's my trusty viewer here, and I'll paste in. There you go. So what are we doing here? Well, we're inserting into a table. We're merging on the people table, and then a whole bunch of other commands down here. And these names are not human friendly. Okay, so values P0, P1, P all the way through what, 299 as values. So not ideal. But what this is doing is it's batch inserting. And the way it's doing that is it's creating a store procedure or a call that has a lot of parameters. And then it's sticking all the values, 299 of them, or actually 300 because I think the first one's 0. Yep, P0. So 300 values in at a time and sending it through to SQL. But it didn't actually create a store procedure for it. And that's what normally we do. We create a store procedure to do this bulk insert. But this is a one-time thing possibly, or maybe it happens all the time. Entity Framework doesn't know. Therefore, what it's going to do instead, and this is what happens for all inserts, and this is another thing I do not like, is it says execute sp _ execute SQL. This is a store procedure you should never use. Okay? Don't use this. And I say never, and that's a little tongue-in-cheek because, yes, there are exceptions to every rule. But I want it to be an absolute exception. Don't use this. This is dangerous. Now, Entity Framework is not stupid. The developers are not stupid. This is a very smart tooling system. I said it before. The tooling is excellent. So why is it using something that Tim says don't ever use? It's dangerous. Well, because Entity Framework is a closed system. So we talk about the idea of SQL injection and not letting users write directly to our SQL database because they can inject their own SQL, maybe drop tables or change permissions or cause chaos in our database. This execute SQL does exactly that. It allows whoever passes in any kind of string they want, it allows them to just run that string. And it will run that as a SQL statement. Now, since Entity Framework has created this call, it is safe to call this execute SQL because Entity Framework knows what the data is. It's protected itself against injection attacks. It's protected itself against bad data coming through. And really, we're creating this in a dev environment, hopefully, and testing this too. However, in order for SQL, or in order for Entity Framework to call this SQL, this SP_execute SQL, the user that is in your connection string. Remember I said right now it's a trusted connection, meaning I'm logged in, that's my credentials. But in production, it'll probably be a login in and password. Those credentials, whether it's a logged in user or whether it's the login name and password you put in the connection string, those credentials must have the ability to run this SP_execute SQL. What does that mean? Well, it means that if you have a desktop application that uses Entity Framework and you have to put the connection string on their computer somehow, I mean, it's almost impossible not to. You can talk about encryption all you want, but the user owns one end of that encryption, therefore it's practically worthless to encrypt it. Not worthless, practically. So with that user owning one end of the connection, they have the ability to use those credentials without going through your application. Therefore, you have given that user that has your WPF application or your UWP application or whatever, you've given that user access to run SP_execute SQL on your SQL server and do whatever they want. I don't like that. I hate that. So, just note, that's a danger right there. That's one of my big pushbacks on Entity Framework, is you really cannot lock your database down. It's pretty much open. Those credentials are pretty much full access to your database. I don't like that. I don't like giving the user access to my full database and saying, please don't mess it up. Okay, now obviously, your typical end user will have no clue how to get those credentials, especially if you encrypt them. But not everybody is a typical end user. If you have a person, a disgruntled employee, someone who is just trying to play around, a hacker, or trying to be a hacker, they can mess you up. I'm not a fan of that. Okay? Now, if you have a web application, it's a totally different story. Because web applications, you put the connection string on the server. And typically your server is totally locked down from standard user access. Yes, your server administrator still has access to your server, but your server administrator probably already has the keys to your SQL database anyway. So it is a different story on web, but for desktop apps especially, this is a little more dangerous. So if you watch my store procedures video, I talk about using Dapper with store procedures and how you can lock down database access to only your store procedures, not SP_execute SQL, not select star from table, not even giving a table list, just calling the store procedures that your application needs. So if the user gets your credentials, no big deal. They only have access to what the application already gave them access to. Now, they might be able to bypass some of the some of the restrictions that your C# code puts on it, like a first name must be 5 characters long. Okay, they can probably bypass that. They call the store procedure directly. But that's not nearly as big a deal as being able to drop tables or read personal information that is not theirs to read. All right, so that's the bad side. Now the good side is we've loaded 300 parameters. What are those 300 parameters? Well, if you actually look down here, you'd find them. So here you go. So P0 is 33, P1 is Strickland, P2 is Boone, and so on. And it loads all those up. And what that's doing is it's doing a bulk insert. So it's inserting multiple rows at a time instead of just one row per call. This is more efficient. So there is an efficiency benefit by doing this, but it does require using SP_execute SQL. Now, that was just one. We still have the other two. So we have this call right here, which if we copy this cell, if we bring our text file back up, we Control A and remove everything, paste it back in, it looks somewhat similar. We have a whole bunch of parameters. In fact, parameters starting at number 300 and going through, oh goodness, this one goes through, looks like 2397. Again, a bulk insert. And this is, looks like for email addresses. I believe the other one was addresses. And then we have, whoops, we have one more, and it's this one right here. And this one, if we Control A and paste them in, this looks like this is the people. Nope, this is email addresses, merge email addresses still. So there's another merge there. And yeah, email addresses. Okay, so again, lots of inserts here, lots going on. Or maybe I copied the wrong ones. In any event, let's close that out. There's the 3 calls it made. Now, if I were doing this in Dapper, I would probably loop through all 800 rows and do one insert at a time, therefore 800 calls versus these 3 calls. Is 3 calls better than 800 calls? Yeah, probably. Is it massively better? Not as much as it sounds like. Because I would send about the same amount of information across the wire. A little more. Because, let's be honest, I'm going to do insert into and that statement and put the values. I'm going to call that statement over and over and over again. Well, I'm calling insert into person, these 4 columns. I'm calling that string. I'm passing that string 100 times. And do the same thing for the 400 times for addresses and the 300 times for email addresses or whatever it was. So yes, there's more data I'm going to transfer across the wire to create 800 people versus this call. That's the downside when it comes to Dapper. I'm going to do more work. Now, I could create a store procedure that allows for bulk inserts. That would greatly improve my efficiency. And I could do a bulk insert and do something similar to this without the SP_execute SQL. But it does require me to write that insert statement, that bulk insert statement, and maybe create a table value parameter as well, or maybe 3 of them, 1 for addresses, 1 for email addresses, and 1 for people. So yes, there's more work going on in using Dapper. So in this way, this is a little more efficient. Now, how often do you do bulk inserts in your C# applications? Probably not very often. If you are, I would suggest writing optimized store procedure inserts with bulk insert ability. And that'll be more efficient than even the Entity Framework code. So it's up to you how you do this, but in this case, if we just compare apples to apples, the simple way of doing things, Entity Framework would be more efficient on the insert, but does open us up to more security implications by using the SP_execute SQL and requiring that ability. Now, all of our data is there, so let's bring back to Visual Studio and let's stop our query right here. And after load sample data, which I'll leave there, I'm going to do a very simple query. I'm going to say var people equals db.people. Now, this people is only going to load the people table, but I want the people table to include these addresses and email addresses, which means going to these other 2 tables and loading that. This is where Entity Framework tooling really shines, because I can just say include control dot to add our using statement here. I want to include, I can say the arrow function a dot addresses, and then include e dot email addresses, and at the end I can say to list. What this will do is it will go out to the database, it will fetch all the people, it will wire up or link up the addresses and the email addresses, and give me the whole result set as people. Now I'm not doing any filtering here. I'm just saying everybody, give me everybody, which would be 100 people with their associated addresses and email addresses. The toList is where we actually execute the query. So the toList says, okay, this is the query so far, but now we actually want to bring it down to the client. We actually want the data on the client side. So it's trying to be, again, the tooling is amazing. It's trying to be as efficient as possible. And so if I did a where statement here, it would run the where statement on the SQL side, not on the C# side, even though it looks like it's on the C# side. So we're using link here, but link is working where it's building a query for the server. But let's start with just this really simple query. I'm going to say load this. Okay? And I'll put a breakpoint right afterwards. And let's run this again. Now again, it's going to hit this people count, and it's going to, I'm going to move this down a little bit. It's going to hit the people count and say, nope, there's more than one, therefore don't run this again. So again, select count from people. Notice that call right there. Let's zoom in here. There's that count again. And it said, we don't do an insert again because we don't have to. We've already inserted enough records. We have more than 0. But now we're going to get this batch complete. I'm going to use batch complete because when it's complete is when it gives us all of our memory information. So the batch complete on this query, which I'll copy this and we'll paste it into Notepad in just a minute. But let's come down here and look at what we have for, there we go. We have for the information for this particular row. So we have the duration is 89,533. Seems high, especially compared to our select star, which was only 4,792. Again, kind of a made up number, but it does give us a comparison sake that this is a lot more work. Logical reads 331, and row count. The row count was 1,204. What is that row count talking about? Well, that's the number of records that it returned to our SQL server, or to our C# entity framework. And if you've been doing the math, you may say, no, Tim, it returned 100. So why does it say 1,204? Well, because it actually returned 1,204. Let's first start by looking at the people itself and making sure we actually have the data we need. So let's just pull one up at random, just the first one. We have the ID is 1, first name is Strickland, last name is Boone, email address, there's 4 of them in there, and let's just pin a value here as we have something. There we go. There's our 4 email addresses, that's cool. And our addresses, we have 3 of them. Let's just pin the city and the state. Okay, so we have Martinsville, Waterford, and Wakili. So again, Federated States of Micronesia. Okay, not in the U.S., but that's okay. But that looks like it's all the correct data. And it was so easy to do. I mean, my goodness. That's all I had to do, and I got 100 records back with populated models. That's awesome. And again, that's better than Dapper. Dapper would have taken a few different calls to populate all the values here. I probably would have done a call to people, another to addresses, another to email addresses, and then link them up afterwards using link, and then return the values. So it would have been 3 different calls and we've gotten all the records possibly, or done a little more complicated queries. But I could have probably targeted a little bit better. But there have been 3 calls and then some work on the C# side before I could get to this point. Whereas this is just 4 lines of code. Awesome. Let's hit stop here. And let's talk about this query. I'm going to copy it again. I think I copied it already once. Let's go to a new query window. And I am in the wrong database. Let's go to EFDemoDB. There we go. Let's paste in our query. Well, it's all in one line. That's not great for formatting, but let's fix that. So we'll format it like so. Make it pretty. Okay, so here's our query. We have select, and they do the square brackets a lot. That's okay. That's the recommended actually. But it asks for ID, age, first name, last name, ID, city, person, ID, state, street address, basically all the columns from all the tables. And it says from people as P. Cool, it renamed it P to make it shorter. That's awesome. I told you this tooling was great. Then we have left join. Now, if you're not familiar with SQL, a left join says give me everything from the people table. And if you find matches in the address table, give those values to me. Otherwise, leave them as null. Okay, and it links on the ID equals the person ID. Cool. And a left join here as well. Now, do you know what the problem with this query is? I'm going to give you a little hint. One person, so one person here, how many addresses do they have? Is it 1 or is it more than 1? Well, it's a one-to-many relationship, therefore the many addresses for one person. So what happens when you match up the ID of the address to the person ID, and you say, okay, ID number 1. It goes out to the address table and goes, oh, I've got 3 addresses that match that person ID. So how does it know which one to put in the row? What it does is it duplicates the person. It puts the person 3 times, and it puts each different address on a different row. The same thing happens with email addresses. But what happens because now we've got multiple addresses and multiple email addresses? How does that all work? Let's run it and find out. 1,200 rows. Let's zoom in here. Okay, so we have Strickland Boone. There's 12 records for Strickland Boone. So it sent back the ID for Strickland Boone 12 times. It sent back Strickland Boone's age 12 times. It sent back Strickland's first name 12 times. His last name 12 times. Okay? Now, we have his city 4 times, his other city 4 times, and his other city 4 times. The same with the state, person ID, street address, zip code, they're all duplicated. Why are they all duplicated? Well, different email addresses. So we have 4 different email addresses for Strickland. So those 4 line up with every address. Okay, so there's 4, and there's 4. So that's what happens. As you have more relationships with this left join, where it's a one-to-many relationship, what it's doing is creating duplicate records. Now, you did not see this in C#, did you? So what happened? Well, what C# did was it said, you know what? I probably can't write a more efficient query for this. So what I'm going to do, I'm going to get just all this information. I know it's going to be tons of duplicates. And I'll just eliminate the duplicates. So it says, oh, you know, Strickland Boone, I have that person 12 times. That's probably 1 record. And Strickland Boone, age 33, ID 1. Cool. We're going to make that 1 object. And then I see 3 different addresses, I'll create one for each of those. And then I see 4 different email addresses, so I'll create one for each of those, and so on. So it takes all this data and compresses it down into 100 records with attached objects. Now, if I were to do a separate query where I said, give me all the email addresses, give me all the addresses, and give me all the people separately, in 3 different queries, like I said, I'd have to do with Dapper, I would have 100 people, I would have 400 addresses, 300 addresses and 400 email addresses. That's a total of 800 rows. Entity Framework returned 1,200 rows. And you may say, well, that's not a big deal. Yes, it's a little more. It's 50% more? But it's worse than that. Because when I would do a query for the people, I would get this record once. ID, age, first name, and last name. I'd get that record once. Entity Framework has transmitted that value 12 times across the network. So even though it only transmitted 400 more rows, it has transported a lot more data. So with my little example, we went from 100 records to 1,200 rows fully populated with all the data. Okay, so notice none of these say null. Like these are all full. So 1,200 full rows instead of 800 smaller rows. Okay, there's a lot more data transfer going across the wire. Now, again, this is a small example, and this still is very performant. This is very quick to run, and it's not causing my network to have issues because 1,200 is no big deal. But imagine what would happen if you had 5 or 6 different left joins here, because every one of them multiplies against all the others. So let's just imagine for a minute that this is I have notes about people. So every time I meet up with a person, I attach a note to their account. So I'd say, okay, met with Bob, had a great talk, doing great. And then the next time I meet with Bob, really struggling with, if statements in C#. And I'd put it down. And I have, hundreds of notes for Bob. Now I do a quick lookup and I say, okay, give me all the people and let's go ahead and attach our notes as well. That could be thousands, tens of thousands, or even hundreds of thousands of records for just a few hundred people in the actual database. That's a real performance issue. Now again, you may say, well, yes, Tim, but there's ways around that. Absolutely, there are. In fact, if we go back up to our query, if I don't need the addresses and email addresses, I can comment those out and not include them. If we run this now, and we look at the list once it loads up, it's not going to have any email addresses or addresses in our list. Okay, so let's look here. Address count 0, email address count 0. It didn't load those. Now if we go and look at the profiler and come down here and look at what it did, okay, down here it said row count. It's a little small, but I'm going to tell you, row count says 100. So it only grabbed the 100 rows. It only grabbed, let's just even copy it and do a new query and run this, or at least show it. It just grabbed the stuff on the people table. There was no inner joins. That's much more efficient. So if you don't need those addresses and email addresses, don't include them. That's kind of those big deal things with Entity Framework. But if you don't know and just say, hey, I want that, I want a fully populated object, I want to do stuff with it, well, that's a serious performance hit. So we talk about the difference. Again, I'm a big Dapper fan because Dapper is very, very performant. One of the reasons why it's performant is because it puts in front of you every single time exactly what you're doing. The only way you make that call that gives 1,200 rows back is if you intentionally do it. You have to say, yes, this is what I want. with Entity Framework, it's kind of under the covers. You don't necessarily know what's happening unless you really understand how Entity Framework builds its queries. And this is a very, very, very simple example. So again, this comes down to this will work just fine in development. This will work just fine until you put it against a production database with a production environment where you have multiple people running this. Because even if you have a production database, or maybe you take the production database, you make a copy of it, you clean out all the sensitive information and use that as your development database, which is a good thing to do. And if you do that, you'd have a lot of those links, and you'd have, a realistic picture of what these queries are going to do. But if you're in development, you're probably only running one query at a time. You're probably only one person at a time. But if this is on your index page of your site, maybe your main page has a list of all the users that are using the system, and they can click on one and it gives you more information about that user. Well, that means that everybody that hits your site is running that query. This is why you will see big load times crash web applications. So if you are a university, or if you are a school and you have a registration period. So registration opens on Friday, make sure you get the class you want. Okay? Guess what's going to happen? Everyone is going to get on your website at the same time. So maybe throughout the year, no big deal. Works just fine if you have, a small percentage of your students on at any one time. During registration time, you have all of your students on at the same time. So if you have 10,000 students at a school, normally you only have, let's say, 300 to 400 users at any one time. But during registration, you have, let's say, 8,000 students at the same time. If that query is a little bit performance heavy, like it is right now when I uncomment these two lines, that is going to crash your website, or possibly. It's going to raise the likelihood of crashing your website. Add that to the Nvarchar max, and you've really got memory issues. Okay? So this is where you have to understand how Entity Framework is building the migrations, and you have to understand how Entity Framework builds these SQL scripts in order to make sure your application is performant. I can't stress this enough. This will all work in development just fine. It's only when you get to production that you're going to have a problem. And let's just say you are a university. I used to work at a university. If my web application crashed during registration, I don't have a year to fix that. I have to fix that within minutes. I have to do something to get registration running, or we're losing thousands of dollars. We're causing massive issues. We're jamming up the helplines. We're causing students to be frustrated, which may mean they don't return. There's an awful lot of repercussions that happen because my software failed at a critical time. That's a big deal. That's a career-threatening big deal. So plan for those instances. Don't just plan for the fact that it runs great in development. Now, there's one more thing I want to show you, and I've just scratched the surface of how to use Entity Framework and what things to look out for. But and there's so much more to cover, but I think we've gone pretty far into this video. I do want to show you one more thing that is an improvement in the tooling. Again, the tooling is amazing. This is an improvement in the tooling in Entity Framework Core. I think 3.0 was when it was improved, and now it's 3.1. So let's just say I have a method. And let's call this method private, private bool approved age, int age. Okay, and it's going to return age is greater than or equal to 18 and age is less than or equal to 65. Okay, and that's going to return basically a Boolean. So is the age between 18 and 65 or not? If it is, return true. If it's not, return false. So that's the approved age. Now, this could be put into a query parameter, but I'm going to put it into a where clause like this. Where x arrow function, I'm going to say approved age for x dot age. Okay, so essentially what I want to do is I want to limit this list of people to only people that have an approved age between 18 and 65. Now, again, I could have said x.age is greater than or equal to 18 right in this query, but this is just a demonstration purpose. What's the difference between, I'll just write it out the other way, where x arrow function x.age is greater than or equal to 18 and x.age is less than or equal to 65. What is the difference between these two lines? Okay. This seems like it's a little bit more easy to read. Instead of putting our evaluation right in line, we have broken it out into a method. Cool. Not cool. Not for Entity Framework purposes. For C#, not a problem. For Entity Framework, this is a problem. And why is that? Well, this where clause can get converted into T-SQL and run on the SQL server. Remember that all this code up here is trying to run at the SQL server, and then the toList actually brings down the results. However, this code right here is C# code. How would you run C# code on the server? You can't. Not really. And so what would happen is, and this is what happened in Entity Framework 6, and this is actually a big problem, is this would say, yeah, that's no problem. Let's go ahead and do it. And it would run that approved age in the where clause. And so user would go, cool, those two lines are equivalent. Nope. What would happen is it got here and said, oh, I have to run C# code against my query. Therefore, do this part of the query, download it, then run this method here to filter out the list. So if you were expecting to get back, let's say 500 records, or 50 records out of the 100 users, if you're expecting 50 users, and you get back 50 users. However, the SQL call and the download would download 100 users, all the users, and then filter them. So instead of, let's just say 600 total rows, remember it does 1,200 rows for 100 users, instead of 600 rows for those 50 users, you're downloading all 1,200 rows for only the 50 users because you're basically deleting half the data. Entity Framework 6 wouldn't tell you that's a problem. Let's see what happens now, because right now it's not telling me this is a problem. Okay? I believe it's supposed to. I believe there's a way to turn it on so it does tell you. And it may be in the tools options. Let's just search for Entity Framework. Nope. Preview features. Nope, not here. It may be in my preview version of Visual Studio. I'm not currently using the preview version. This is, let's just check. This is 16.4.2. Okay, so it currently is not telling me there's a problem here. But let's run this and see what happens. There's no breakpoints here. It's just going to run. Actually, you know what? I'll put a breakpoint right at the end, hopefully. Right there. Before it even gets to the breakpoint, it goes, no. The link expression could not be translated. Either rewrite the query in a form that can be translated or switch to client evaluation explicitly by inserting a call to either as enumerable, as async enumerable, toList, or toList async. Okay? What it's saying is it can't translate this. And as a user, you might not know what that means. And you may say, what do you mean it can't translate this? Well, let's do this. I'm going to put my semicolon here. I'm going to comment this out. And I'm going to put a toList right here. That's what it said to do. Do the toList before your where clause. Right? Let's just, or let's just clear this out. Clear data. Okay, we're gonna start over. So let's run this again. My breakpoint's in place. I've moved my to list. And let's run this and see what happens. Okay, I hit my breakpoint. Cool, it worked. Awesome. Come over here, and we've got a batch here. Notice we have our counts, so select count. Then we have a SQL batch, and notice right down here, row count is 1200. So what did it do? Well, it did just what I said it would do. It downloaded all of this data, and then it did the query based upon this where clause. Therefore, people, okay, people has a, let's expand this out. People has, let's look at it. It looks like 55 people in it. Something like that. It's IEnumerable. I didn't do a to list. So I could have done a to list at the end of this. I probably should have. But it's only got 56 people, including the 0. 56 people in this record. Well, that's different than the 100 I was expecting. Or I'm sorry, that's different than the 100 I downloaded, but it is what I expected. I expected 50-some people because that was my range that I filtered. It's probably in the middle somewhere, and probably half of them or so are in that range. So I got the values back that I expected. And so if I didn't look at the SQL query and see what it was doing, I wouldn't know that I just made this query terribly inefficient. And I even did what the exception said to do. And therefore, it made it terribly inefficient. Okay? Now, let's get rid of this to list here. Let's uncomment these two right here. And let's comment out the bad one. Okay? Let's run this again. So, I'm going to run it again. And I did to list at the end this time, so I should have my my count. So count is 56. Cool. If I go over to SQL, come down here and let's zoom in on my my row count. My row count is 673. That's much different than 1200. Okay, it's almost half. Why is it almost half? Because we had only 56 people come through. And those 56 people had the 4 email addresses and 3 addresses. So it's less records than all 100 would have had. So, by either changing my where clause or by not doing it, I'm able to have a more efficient query. So just because the exception says, hey, put to list before this where clause, don't do it. Not if you can help it. Because you're bringing all these records down to the C# to then do the work. If you can help it, let SQL do what SQL is best at. SQL is best at storing and retrieving data. Yes, C# can do it. And yes, there are times when C# needs to do some filtering on its own. However, the bulk of the filtering and querying work should be done on the SQL Server. So, that's why if you can write your query like this, as opposed to a separate method, it's important that you do. Because therefore, it will do this query on the server. In fact, let's go look at that query real quick. I'm going to copy this, and then I'll open up Notepad again. I closed it, so let's open it back up. Let's paste this in. And looks like I have word wrap turned on. So there's our, let's just kind of wrap this up ourselves like so. And there's our select statement. There's our from, there's our left join, there's another left join. Here's our where clause, and there's the order. So where clause, where age is greater than or equal to 18 and age is less than or equal to 65. Cool. So it took our C# code and translated it into a T-SQL query on the server so that we didn't have to download all those records. So, the key thing, the best practice here is when you've got your link statements, don't call C# methods. Put the code right into the where clause if at all possible so that it can run on the server. Now it should tell you in EFCore that there's a problem if you try to do this code. In Entity Framework, it won't tell you. It will just run this code by first downloading this data and then running it against this method. So that's where you really have to understand how to look at these queries, see what's going on, and make sure that that's the query you want run. So to recap, you need to know how your migrations are working and make sure that the migration data is correct and it is efficient. So you have to make sure that you decorate your models appropriately. Things like changing to Nvarchar instead of Nvarchar, changing the max length, making them required. These things are important to do. Okay? That's from the design perspective. The next thing you need to do is make sure that when you're writing your queries that you don't do these includes unless you absolutely have to, and that you know the implications of using that include and what it's going to cost you. You also need to make sure that you don't call C# methods in your query until after you download the data. But note that once you've downloaded the data, you're downloading larger chunks if you only filter after you download. So if at all possible, filter before you download. All right? So you also need to know how to use the XEventProfiler or something similar in SQL Server, or some way of knowing what commands are being run on your server, how efficient they are, and what you can do to improve them, because it's very, very important. Now let's talk about, as we wrap up here, why would you use Entity Framework? What are the benefits of Entity Framework? So I'm going to put right up here in the comments, benefits of Entity Framework. Let's just put Core. I mean, it's Entity Framework or Entity Framework Core, okay? It's up to you. So the first benefit that I hear a lot is faster development speed, okay? I get that. Obviously, this was super fast to do, okay? And I got all those models populated. It just worked. It was quick to develop. But it was slow in production. Yes, there are things you can do to improve the performance, but that means either writing your own stored procedures, which negates the purpose of doing this, or you can not include some of the data, which again negates the benefits you're getting from Entity Framework, or you just live with the fact that yes, it's more data, but hopefully we won't need that extra performance. Okay? So that's issue number one, faster development speed. Absolutely. It is quick to get Entity Framework in and running. However, as we've seen, it slows way down if you want to make sure it's performant. So yes, you can shoot yourself in the foot fast, but maybe you shouldn't shoot yourself in the foot. Maybe you should review what your creation scripts are like, what your table design is like, and make sure it's correct. That takes some time. Maybe you should decorate your objects and make sure that they have the right decorators. That takes some time. You've now lost some of the benefits that you got from Entity Framework because you're trying to be performant here, right? So faster development speed, yes. But if you want it to be performant, then that development speed is greatly reduced. So the next benefit I see from people is you don't have to know SQL. Okay? I think I've proven that's not the case in this video. Because if you don't know SQL, you're absolutely shooting yourself in the foot. Because would you have known to go in here and would you have known what Nvarchar max meant? Or would you know it works? You probably know it works. Would you know what this table even meant and know that, oh, 272 kilobytes is pretty bad and we should make a change so we're not using that anymore and use instead, Nvarchar 64 or 256 instead? You probably wouldn't, because you wouldn't even know how to do that, because you wouldn't understand the different data types in SQL Server. So, would you know, if you don't know SQL, would you know how to use the XEventProfiler to see how many records you're downloading from every query? Or how to optimize your queries by looking at this and making tweaks to your C#? Nope, wouldn't know how to do that either. So therefore, if you don't know SQL, you really shouldn't use Entity Framework because you will burn yourself. Now again, if you're going to do small applications, if your applications aren't going to production, if you are building demo applications or applications for very small companies that have very few users, then you probably won't ever see a problem with the Entity Framework. Okay? But if you ever intend your application to grow in any size, it will be a problem. You will have to optimize it, which means you will have to learn SQL and you will have to slow down your development speed. Now, having talked about the fact that our scripts, let's say this validation script here, remember we ran this, in fact, it might even still be here. Yep, an operation with scaffolded that might result in a loss of data. Please review the migration for accuracy. How would you do that if you don't know SQL? How would you know what's happening? You wouldn't. Maybe you do know SQL. What are you going to have to do to evaluate this loss of data? You have to go in and do some queries. We're truncating these 10 columns. Is there data in those 10 columns that is going to get truncated? You have to go to SQL Server Management Studio, run some queries, find out, figure out what to do with that data, and maybe make sure you have good backups. Have you done any of that? Probably not if you don't know SQL. And even if you did, you've now slowed your development speed down because you have to be responsible with your data. All right? So I really don't see benefits number 1 and 2 being that valuable for Entity Framework. It is absolutely faster to develop, and you don't have to know SQL. But as we've seen, if those two things are true, then your database is in danger. I don't like creating databases right out of the gate that are in danger. Production databases can have thousands, hundreds of thousands, millions of records. If you are not very careful with how you do queries, if you're not optimizing your queries for performance, then you're going to slow your application to a crawl. And it's going to happen in production at the worst time. Whether you're an e-commerce site and you have a sale going on, and that's when it crashes your website, or you're a university and you crash during registration, and there's so many other possibilities based upon your industry, that's when it's going to happen, or most likely going to happen. And if that happens, then you're on the hook and there's not a quick fix. Now, you may say, Tim, I've been working for 20 years. I've never had a problem. Great. That means one of two things. One, you're throwing lots more resources at it than you need to. Or two, they're not that big. Okay? One of the two is the case. Either you're not doing tons of queries and you're not bringing back lots of data, or you're throwing lots of resources at your servers in order to keep them performant. Neither of those is terribly efficient. Okay? Either one, you're not doing a lot of work, in which case you're not doing a lot of work. Or two, you're throwing lots of resources at it that you don't need to, and therefore you're paying for them. Okay? You're paying for whatever resources you have. If you have your application in the cloud, then you're a little more visible in how much you're paying for your application. If it's on premises, then you're probably paying by buying bigger servers than you really need with lots more memory than you really need. And you're having a lot more energy usage from those servers. So you may get by and never see an issue. But if you do, it will happen at the worst time. Now, you've heard me say that I like Dapper. And if you've watched any of my videos, I prefer Dapper. Okay? So let's talk the benefits of Dapper. Goodness. There we go. All right. So benefit number 1, faster in production. That's just going to be the case. Okay. Dapper is practically as fast as ADO.NET. ADO.NET is pretty much bare metal calls to the database. So you're not going to get faster than Dapper in almost any case. Now, there might be a case where you get Entity Framework as fast or practically as fast. But again, that's if you slow your development speed down and you do know SQL and know how to optimize your Entity Framework core, if you are an advanced user of Entity Framework core. And again, if you are an advanced user of Entity Framework core and know how to optimize it, cool. Absolutely use Entity Framework core. It's just that people don't come out of the gate knowing Entity Framework core. There's massive books. There's tons of video content. There's lots of blog posts on how to make Entity Framework performant, how to use Entity Framework in general, and how to work with this inside your application. The reason why? There's a lot to know. If you know it, if you're great at it, if you're an expert, cool. You will do a great job and make it performant. With Dapper, yes, development is going to be slower, but it'll be faster in production. You'll know that you've optimized for production. Therefore, you don't have to worry about or worry as much about the scale that your application hits because you have optimized the database portion of that scaling already. You've pre-optimized your application for database performance because you want fast in production. Fast development speed happens once. Production speed happens every day. I value production speed much more than my development speed. I love how fast Entity Framework core can be developed. I want a faster production speed for my application. Okay? Dapper is easier to work with for a SQL developer. You can, in about 4 lines of code, call a store procedure with parameterized SQL for your data. Really quick. I have a little snippet that I've created that actually turns it into 1 line of code. 1 line of code, and I get data from the database, I put it into a model, and I have that list of model on my computer. That does mean I have to write a store procedure, or I have to write a T-SQL statement and pass that in instead. Yes, that means I have to know SQL. But with that, I can be faster in production, and I know exactly what data is coming across the wire. I know exactly what my query is doing performance-wise, and I can make a change to that very, very easily. If you have to change this query to be more performant, what do? I mean, seriously, you'd have to rework how this works. You'd have to make some kind of weird link changes to get this to be different. That's not ideal because you have to really dive deep into Link and to Entity Framework and understand how it creates queries and make some changes. If I'm writing a store procedure, I can just change the T-SQL that's inside of it. Simple as that. Okay? The third benefit I see here is that it's designed for loose coupling. Now you notice I put my Entity Framework in a class library, but it still kind of fought me. And in fact, if we look at our dependencies in our NuGet packages, we'll see that I have Entity Framework Core tools installed. And if we go to Startup, you'll see that I'm actually using Entity Framework Core in my front end, and it knows about SQL Server and the DB context. It knows about all that data access stuff and Entity Framework stuff in my front end. That's a little less than disconnected for me. This, Dapper, I can create a class library that just sends back models. You don't know how it gets them. It just sends them back. And so that's a little bit more, it's a lot more loosely coupled as for an application, which means that I can create a data access library and pass that around more easily to different applications. Entity Framework, a little bit more complex to do that. Possible, just a little more complex. Now, this is not a EFCore versus Dapper video. I'm just kind of pointing out the highlights here of why I still focus more on Dapper than I do EFCore. The other part of that is this channel is focused on helping developers learn C#. I do teach Entity Framework Core in my Foundation in C# course series, but I wait until Module 8, and that's only after I have taught data access directly using Dapper for SQL, SQLite, MongoDB, and others. Then I teach Entity Framework Core, and I walk through some of these examples and talk through why we don't just use this tool all the time. Because this Entity Framework Core, this is dangerous. And that's what I talk. My illustration in the course is that, have you ever seen one of those big earth movers? Those really, really big machines? That's what Entity Framework Core is. It's a really powerful, awesome machine. But to get in the cab of that machine and drive it and operate it, you don't just decide one day, I'm going to do that. You get trained on it. You get licensed to use it. You have an instructor teach you how to use it. It takes time to get in that cab and operate it. That's kind of like what Entity Framework Core is. It's that big earth mover. It's dangerous to use if you're not really experienced in it. And it can really bite you. And the worst part is the danger doesn't show up until it's too late. So that's why I say Entity Framework is a great tool. My issue is who uses it. And I say that this is an advanced developer tool that only advanced Entity Framework Core developers should use. Again, not trying to gatekeep here. I'm trying to protect you. I don't use it. I prefer to have that control with Dapper. Again, I am a SQL developer. I do know SQL. I do have a course on teaching how to become a SQL developer. Not hard. But that way I see what's going on immediately. I can make changes directly, and it's designed to be faster in production. And it's really easy to be loosely coupled. And really, my Dapper code, one line. For writing or for reading. One line of code. And then just your SQL call. So with that, it's not that much slower than Entity Framework Core. But the results are faster in production, easier to work with, and more loosely coupled. Okay? So that's my take on Entity Framework. That's my my issues with it, and some of the best practices that I've seen using, even the basics of it, and also the pitfalls you need to avoid. So really understand how your SQL works, really understand how Entity Framework creates your SQL, and how to diagnose that SQL is being called and make modifications to it. Okay? So if you're going to use Entity Framework, I definitely encourage you, become an expert in it. Practice it a lot. Really look at what's going on in your SQL statements, monitor them, understand the performance benefits and drawbacks of everything you do, and know how to work around some of those performance issues that are going to happen. So if you stuck with me this long, I would love to hear your thoughts in the comments. I would love to know What do you think I missed as far as the performance or the issues that occur in Entity Framework, or the benefits that I missed in Entity Framework? Let me know what you think of using Dapper versus Entity Framework. Again, just please keep it civil. This is here for us to grow. I would love for all of us to get better. Again, I'm not a huge Entity Framework person, so I'm sure I missed stuff. So if you want to say, hey, this would make your query better, or this would improve things, that's great. And I would really appreciate that. Now, that is proving my point a little bit, because again, if it's not obvious that this will improve your query, then it's not something that a beginner or intermediate developer will do. And that's okay. I would love to become an expert in Entity Framework Core, because I'd love to use some of this power. I mean, this is pretty powerful stuff that's pretty easy to do. So definitely if you have suggestions, that'd be great. I'd love to hear them. Okay. Now I do have also a blog post. I'm going to bring it over right now. I wrote this back in August. I rewrote it. I had on my old site, I had a post, and I kind of rewrote it. And this is my thoughts on, should I use Entity Framework? And my answer typically is no. So now I do point out, hey, real programmers, they often think I'm an idiot. And DBAs, database administrators, often cheer. Okay, I've been to both kinds of conferences. I've spoken at conferences in front of developers, and they're like, why don't you use Entity Framework? That's just obvious. That's simple. And I've been to conferences speaking in front of database developers, and they're like, oh, great. Like, thank you. Don't use Entity Framework, please. Okay? And so there's both sides of this, but there's much more nuance than either camp wants to admit. So I talk through that nuance. Okay? So give us a read. Let me know what you think. It asks some good questions here. Some questions like, does your team understand how to use Entity Framework well? That's more than just knowing how to write link queries. Does your team know how to diagnose issues with a code or underperforming queries? Okay. And do you know how to protect those client credentials? If you're using WPF or WinForms or Console, you're possibly giving away your credentials. That could be an issue. And so I did some comparison here, and I do talk, there's that video on store procedures where I talk through the security of your database and how you can lock down the security even without encrypting your credentials, which I said for a desktop application doesn't do that much benefit. Okay? And then I talk through the connecting to SQL using Dapper, right? So that article I'll link down below in the description. Give that a read if you want more information. I didn't cover all of this in the video, but that might be of benefit as well. So again, give me your thoughts. I love to talk through this with you and hear what you have to say. All right, thanks for watching. I appreciate the hanging in there for this longer video. And as always, I am Tim Corey.